Hello and welcome back to my channel. Today we are starting exercise 1.2 of real numbers. So let us start from the first question, and first prime question is very easy as a do the prime factorization of following. Four parts are there. I am telling you one of the part, prime factorization of 3825, third part. Very simple, as you were factorizing, factorize it 3825. So by 5 sevens are 35, 3 is left, then 5 6 are 30, 2 is left, 5 5s are 25. Then again by 5 ones are 5, 2 is left, 5 5s are 25, 5 3s are 15. Then 5 6 7 8 1 9, it is divisible by 3, 3 5s are 15, 3 1s are 3. Again it is divisible by 3, 3 1s are 3, 4 5 2, 3 7s are 21. Then it is divisible by 17. So the prime factorization of 3825 are 3 into 3 into 5 into 5 into 17. That's it. Only this much you have to do, nothing else. Only the prime factorizations. It's very easy then. Come to the next question. Second and third questions are find the LCM and HCF of the numbers. So second question and third question. So second question, let us take find the LCM and HCF of 26 and 91. Okay, so let us write 26. Do the prime factorization of 26 with 2. 2 into 13. Okay, 13 cannot be factorized. Now 91. 13 sevens are 91. So I am writing this. HCF. What is HCF? Factor, highest common factor. So nothing is common, only 13 is common. So I am taking this. So the HCF is 13. Then let me find LCM. LCM, whatever is common, you have to take it one time. Then whatever are left, we have to multiply by it. 7 into 2. So 7 2s are 14. 14 into 13 is 182. So these are the LCM and HCF. If it will come to verify it, that LCM into HCF is product of two numbers. So you have to verify that LCM into LCM is product of two numbers. This is the formula also. LCM into HCF is product of two numbers. So what is LCM? LCM is 182 into HCF. What is HCF? 13. Product of two numbers. What are the two numbers? 26 and 91. The two numbers which are given. Easily you have to multiply. You multiply this and whatever the answer will come, and here you multiply this. Both should be equal. Then you will write left hand side is equals to right hand side. So you will write then hence verified. Simply you have to do only calculation. Okay, so let us come to third question, which is also same. Find the LCM and HCF of the numbers. So here three numbers are given. Difference is this, here two numbers are given. Now in third question, three numbers are given. Let us take one of the part. Let me take the third part. 8, 9 and 25. So you have to find the LCM also, HCF also. The prime factorization 8, 2 into 2 into 2. Then 9, 3 3s are 9. Then 25, 5 5s are 25. So therefore HCF is equals to whatever the common in these three, that is the HCF. Now you can tell me what is the common. 2 is here, 2 is not here, 2 is not here, 2 is here, 2 is not here, 2 is not here. 3 only in this, not in this. 5. So in all three, nothing is common. So the common is 1. 1 we have not written, but the 1 we have multiplied, if we multiply it by 1, so no effect. So 1 is common, so HCF is 1. Now we have to find LCM. Nothing is common, you have to multiply all these numbers. So 2 into 2 into 2. Into 3 into 3 into 5 into 5. So what will be there? 5 2s are 10, 10 5s are 50, 50 to the 100, 100 to the 200, 3 to the 9. 200 into 9, 1800. So their LCM is 1800. So the HCF is 1 and LCM is 1800. Done? Let us come to next question. That is our fourth question. The fourth question is, we are given HCF of 306 and 657. HCF of 306 and 657 is 9. You have to find the LCM of these two numbers only, 306 and 657. So how to find? You knows the formula. What is the formula? LCM into HCF is equals to product of two numbers. What are the two numbers? These two numbers. So 306 into 657. What is the LCM given? You have to find it. So this LCM you have to find. So LCM I am writing as it is into HCF of two numbers is 9 is equals to these two numbers 306 into 657. Send 9 this side, it will go in division. LCM equals to 306 into 657 whole divided by 9. So cancel it. 9 3s are 27. 3 is left. 9 4s are 36. When you will multiply these two numbers, it will come 22338. So this is your LCM. Like this you will do LCM. Come to our next question. Question number 5, which is very important as the point of view of board examination, because so many places and so many sample papers you will see this question, these types of questions. Now the question is, fifth question, check whether 6 is to the power n end with digit 0. And in example you are given the check whether 4 is to the power n end with digit 0, or you can check any other number 10 is to the power n end with digit 0 for any natural number n. That means n is natural number. What does it mean? N can be 1, 2, 3, 4, 5, 6, 7 up to so on. N can be any natural number. So you have to check whether this digit and this digit end with digit 0 or not. Okay, that means one's place is 0 or not. So let us see. 6 is to the power n. What is the prime factorization of 6? 2 3s are 6 raised to the power n. We can write it like this. Okay. Let us put for n equals to 1. Okay, for n equals to 1. So 2 into 3 raised to the power 1. So it will remain like this. 6 only it will come. Let us put n equals to 2. So see, 2 into 3 whole raised to the power 2. That means 3 to the 6, 6 square. 6 is a 36. So answer will come 36. And if we will put n is equals to 3, so that means again 6 raised to the power 3. See the unit place. 6 is the 36, 36 is the 216. In the unit place 6 is coming. So that means if you will just put any of the number in the place of n, only in the unit place 6 will come. That means it will not end with digit 0. So we will write, because there is no prime factors other than 2 and 3. So therefore it will not end with digit 0. So this I am leaving. We will do together. 4 raised to the power n. Let us see till here. 2 into 2 raised to the power n. What can we write? 2 square raised to the power n. We can write like this. So 2 raised to the power 2n. This is this. Let us put n is equals to 1. If we put n is equals to 1, 2 into 1, 2. So it is 2 square. For n is equals to 1, so it is 4. When n is equals to 2, 2 to the 4, 2 raised to the power 4, 2 to the 4, 4 to the 8, it was 16. So if you put any of the number in the place of n, never it will end with digit 0. Try it yourself. Then let us take 10 raised to the power n. Okay, so 10 raised to the power n, what you do? 2 into 5 whole raised to the power n. You can write it like this. So now 5 2s are 10. 10 raised to the power n. If you put n is equals to 1, so 10 raised to the power n is 10. If you put n is equals to 2, so 10 raised to the power 2 is 100. If you put n is equals to 3, so 1000. So this is ending with digit 0. Ones place is 0. What you have seen from these three examples, that if there is prime factorization 2 and 5, 5 is the prime factorization with 2, always the digit will end 0. Here is 2 but 5 is not there. So there is no prime factorization 5. Here is 2 but 5 is not there. If you put 5 here, so try it. So it will always end with digit 0. So what will we write? And the end in every number, because there is no prime factor 5, therefore the digit will not end with 0. Very important question. In these two cases, this will be written at the last. Okay. So this is your fifth question. Now come to the sixth question. This sixth question also you will see in so many places. So let us see the sixth question. Hope you are understanding it. It should be very clear to you, because once it is clear to you, you will not forget it again. The basic concept should be clear. Concepts are not clear, don't learn them. Okay? So let us see the sixth question. Explain why 3 into 11 into 13 plus 13 and one more number is given, 7 into 6 into 5 into 4 into 3 into 2 plus 1 into 1 plus 5 are composite numbers. I told you in the last video what are composite numbers. Composite number which are having more than two factors, which is divisible by itself and some other number also. Okay, one in itself it will divide, but it will divide by some other number. And last video I told you 4 is the smallest composite number because it can divide with 1 also, 2 also and 4 also. 3 factors, 1 and 4, other than 4, 2 also. The smallest 4 is the smallest composite number. So we have to show that these two are composite numbers. So that means they are having more than 2 factors. Okay. So how we can do? There are two terms. One term is this and one term is this. Everybody knows plus and minus separates the term. Take 13 common. Okay. What is left? 7 into 11 plus 13 is it? 1. So 13 into 7, 11 sevens are 77 plus 1, 78. So you can see this plus sign is removed. Now this comes in a form of multiplication, and you can factorize this also more. 13 into you can factorize, and if you are leaving this, so then also if you will say because the number is having more than 2 factors, 2 prime factors, you can just multiply, just also spread these in so many factors and say there are more than 2 prime factors, so therefore the number is composite number. Similarly in this also there are 2 terms. One term is this and here plus comes. So second term is this. Take 5 common in both of them. What is left here? 7 into 6 into 5 is common. 4 into 3 into 2 into 1 plus 1. If you solve all these, this multiplied by plus 1 into 5, it will come 1045. And if you just split this, it will come 5 into 11 into 19. So you will say this number has more than 2 prime factors, therefore this number is a composite number. The last one and this one are very important question for the board examination. Don't leave these two questions. And the last question now left is 7th one. Hope you are understanding, and if you are understanding, practice it in your rough so many times you will not forget. Then last question is, there is a circular path. 7th question. Circular path. This is a circular path. around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Where Sonia is starting, it is taking how many minutes? 18 minutes. And Ravi, it is taking, from here it is starting, again he is coming here, he is taking 12 minutes for the same. Suppose they both start at the same point. That means both are starting at the same points and at the same times and go in the same direction. After how many minutes they will meet again in the starting point? So that means first round if will take, definitely they will not meet together because Sonia is reaching in 18 minutes and 12 minutes. So that means after how minutes means after more minutes they will just meet. If they are starting at 0, so they will start after 0, 1 second, 2 second, 3 second, 4 second, 5 seconds and go on increasing. So bigger number is there, they will meet more than after 18 minutes. So we will take the LCM, multiple of these. If HCF is the factor, less than this factor, if we will take out HCF, so less than this will come. So they will not meet after this in one round. So we have to take out the LCM. So take out the LCM of these two numbers. LCM is the meeting time of 18 minutes and 12 minutes. 2 9s are 18. 9 can be written as 3 into 3. 2 6s are 12. 2 3s are 6. What is the LCM? 2 is common, 3 is common. So 2 and 3 will take one time. Then 3 into 2 will take. 3 3s are 9, 9 2s are 18, 18 2s are 36. So after 36 minutes they will meet together. Write in words that after 36 minutes they will meet together. That's all for today. Thank you very much. Keep watching the video. Do like and share and subscribe it. Press the bell icon. Bye bye. Thank you.